So I am Dr. V. Sivasubramanian, Associate Professor and specialized in algology. In fact, I did my PhD in marine diatoms. So actually I cultured about 250 diatoms from Indian Ocean and other places, and selected a few diatoms for further studies on ecophysiology. And during my MPhil also I did work on fat accumulation in a pennate diatom, and I identified various methods by which you can induce more fat accumulation in diatoms. So that has become a very important paper now when people talk about oil from algae. So diatoms are one of the organisms that are favorite organisms for biofuel resources. Now I am working on effluent treatment using microalgae, especially green algae and blue greens, and applied to various industries. So one of the first industries we applied is alginate industry, that is working for the last 5 years successfully. And after that we have implemented in confectionery industries, leather processing chemical industries, the textile dyeing industries, electroplating industries, and other food industries, where the main idea is to correct the pH, remove sludge, reduce BOD, COD, and also degrade or convert or accumulate heavy metals, and also degrade other organic acids and other chemicals. So this we have achieved in so many industries. Now it is very popular in India. So more and more industries are looking forward to adapt this technology. And we are also going into algal farming. Algal farming activity is becoming more popular nowadays, and more investors at industries would like to grow algae for biomass. And the biomass as an application like biodiesel, biofuel, other biofuel like bioethanol and all that, and also biofertilizer, and use biomass as nutraceutical and pharmaceutical resources, and also animal feed, cattle feed and aquaculture feed. These are all applications. We call it as biorefinery approach. So the companies like cement factories and other industries are coming forward to grow algae. In fact, we are starting a farm in one of the cement industries in Rajasthan, where they want to grow algae in abandoned mines, where naturally looking ponds are available, and we are going to propel the paddle wheel using windmill generated energy, and we are going to grow algae in huge volume and then harvest the algae and use it as a fuel directly in the furnaces, in the kilns. So it is going to be co-fired with coal. So we have calculated, the industry also has calculated, if we can replace 5% of coal with algal biomass, they will be saving around 10 crores of rupees, in Indian rupees, 10 crores per year. That's a huge saving, apart from the carbon credits and other benefits they will derive out of this. So this is becoming more and more popular now. So now we are talking about integrating phycoremediation with algal biomass production, because algal biomass production, if we produce for nutraceutical and pharmaceutical and cosmetic application, it can be costly. The per kg can be even sold at 600 to 1000 rupees. But if you want to grow it for biofuel, other purposes, and cattle feed and chicken feed or aquaculture feed, it should be cheaper, so that it can compete with the existing market. So to make it cheaper, the major inputs are about 30% of investment goes for nutrient input. So that can be avoided if you use industry waste, industry sludge, sewage and other wastewaters, where naturally richer nutrients are available, and these algae can very well grow in those hostile conditions, because they are very simple organisms. They adapt very well to any kind of hostile situation. Only thing is you have to screen and identify which organism is suited for your own climatic conditions and your own area and the kind of water you are going to grow. That is the only thing. So that is the big headache for the scientists to isolate and look for algae. And India is blessed with huge volume of algae, and because of the tropical climatic condition, hotter climate and high light intensity available throughout the year, that is very good for growing algae. And we are blessed with algae. We are blessed with the parameters which are needed for algal growth. So it is for us to use the algae to our advantage. So sewage treatment using algae is one of the important aspects of application of algae. In fact, Osborne and others in USA, they started applying algal treatment system for treating domestic sewage. In fact, domestic sewage can be a very, very comfortable medium for algae to grow, and it has all the nutrients. And compared to industry effluents, this is a very simple, very easily can grow algae in domestic sewage. In fact, the domestic sewage has the high BOD, high COD, and odor and color. All these things can be removed. Every household can have a treatment system. Apart from their regular treatment system, they can have a secondary or tertiary treatment using algae, so that the water that is treated is completely stripped of the nutrients and color is removed. The water becomes so transparent. In fact, you can even think of recycling the water, reusing the water by putting it through RO plant. If not, you can even use it for growing fish, and if not, you can even use it for gardening and other purposes instead of letting it out in the natural water. So in the future, when there is a water crisis, we have to use the wastewater effectively. So algae can be the only solution, because algae are photosynthetic, they are not pathogenic, they are not harmful. So they evolve oxygen and oxygenate the atmosphere. So oxygenation is a major advantage. So the future, I look to algae as saviors from various problems, global warming, the pollution, energy crisis, and food crisis. In fact, another very important application people can think of, and I think nobody has worked out also, on oil slick, how algae can help. In fact, our experience with oil is really positive. So when we are doing an effluent treatment with algae with one of the industries in Andhra Pradesh in India, where they have an ETP plant for treating waste from oil drilling process, a lot of sludge and water. The sludge has about 20 to 25% still oil sticking onto it. So we have used some species of algae which you are able to reduce the algae, the oil percentage less than 2%. By treating it, we have designed a treatment process by which you have treated, and the whole sludge now becomes a cultivable kind of soil. So that's the advantage. The texture improves, the organic content improves, the water holding capacity improves, the oil is gone. Now we are growing plants in this treated sludge, and that is one of the advantages. In fact, the same species of algae can be tried to deal with oil slick whenever it is not possible with other chemical or physical solutions. And talking about the industrial collaborations that we have done so far for the last 10 years, it may look, if you go through our website or the papers or reports, it may look very simple, that you can easily walk into industry and convince them. That's not easy. It's very, very difficult to convince industries. In fact, as long as you are in the laboratory, you have control of all the parameters. Once you go out of the laboratory, talk about large scale, you don't have control of almost 99% of the parameters. You don't have a control. You have to interact with engineers and other industry people, investors and commercial fellows to convince them. And industries, unless they are convinced about the economic viability of the project, they will not support. Unless you have a support from the industry, you cannot implement whatever beautiful ideas you have. So you need investor, you need the industries, but you have to convince them. That is a major task. And for convincing the industries, you should have a background and a solid research experience and also the data addressed towards tackling problems of the industry. But unfortunately in India, and also in many places in other part of the world, the academic research or academic institutions, they have no connection to industries. Similarly, industries have nothing to do with academic institutions. Academic institutions think that industries are doing something that is not relevant to them, and industries feel that academic institutions talk about something, read something and learn something that is not directly relevant to their problems. But in fact, if you visit industry, you will realize that academic research, academicians can do a lot of things to solve problems, day-to-day problems faced by the industry. One of the problems is pollution. And in fact, in the product development and product process also, the academicians researchers can help. So you have to reorient your syllabus, academic syllabus, and have a focus on industrial problems. Then you can develop students and the trained people who have a direct, they can be very easily accommodated by the industry, taken by the industry for tackling their problems. So when we visited industries earlier, we had to have several visits earlier, try to convince them for every visit. In fact, we had to spend more than 3 or 4 hours by putting up PowerPoints and then discussions and answering their questions. So the main thing you should have is, you should have answers for all questions they will ask. You cannot say, I don't know. You cannot say it may be possible. You cannot say that maybe after doing that we may understand much better. But you should have convincing answers. If you want to really go for applying this technology, whatever you want to develop, you have to convince the investors, you have to convince the industries. That's a major problem, in fact. So somewhat we have been struggling for the last 10 years to bridge the gap between the academics and the industries, and we have been partly successful, as you can see from the results we achieved recently. So the major problems that we face today, right from global warming, environmental pollution, energy crisis and food crisis, all these can be addressed using algae. So not because I am an algalologist I am telling this, but there are other reasons. In fact, if you go back in the history of Earth, long back, millions of years ago, when the first photosynthetic organism evolved, that is the blue-green algae evolved, there was no oxygen in the atmosphere. The atmosphere was full of carbon dioxide and there was no ozone layer. So it was much warmer than now. So when the first photosynthetic alga evolved, the globe was much warmer, no ozone layer. So it has to face all these hostile conditions. So it started doing the photosynthesis, fixing the carbon dioxide, fixing them and storing them in their biomass, and also evolve oxygen. So the excess oxygen that evolved, got converted into ozone layer. So the first ozone layer came because of the algal photosynthesis. That paved the way for other organisms to emerge. And in fact, we owe our existence to algae. So when algae started doing photosynthesis, they fixed the excess carbon dioxide and fixed them in their biomass. And during the course of evolution and fossilization, it got converted into fossil oil or crude oil. And more than 99% of oil that we take has come from algae. So it is now natural and logical to go back to algae to save the world again, because algae has already saved us from global warming and also energy crisis. Now it is logical to go back to algae, not only for food but also for fuel, and also to reduce global warming by fixing excess carbon dioxide. So by promoting algal growth, both in effluent treatment, waste treatment, and also algal farming for biomass production, we not only produce valuable biomass, we also remove excess carbon dioxide that is creating problems in the earth now. So now more and more people are aware of this, and in fact if you calculate the amount of oxygen that is evolved by algae right now, more than 50% of oxygen we breathe, it has come from algae. The ocean, the major 75% of earth is surrounded by ocean. Ocean has rich amount of microalgae, including diatoms and dinoflagellates, and they are the major sink for carbon dioxide. So it is for us to utilize those algae. There are about 30,000 to 40,000 species available. So commercially we have probably utilized only a few algae for food and other purposes. But it is for us to look for other algal species for their potentials, screen them, and then try to utilize them to our favor, to clean the environment, to be to increase the energy security and also food security, and prevent further global warming. Nature has all the solutions to the problems we face. It is for us to look for the solutions in nature. So one of the solutions is algae. So algae can solve so many problems. And it is for us to look for these algae, and as kids, as students, you should concentrate more on these algae. Try to grow them in your small tanks or small bottles. Study their life cycle, how they grow, how they divide, how they reproduce. Understand their biology, so that when you want to utilize them later, this knowledge you develop, that is going to be useful. So unless you have a basic knowledge on the morphology and the taxonomy and the identification, the life cycle, and probably basic biochemistry and physiology and ecology, it is very difficult to utilize them in the biotechnological field. So that part is missing. In fact, people want to jump to biotechnology immediately without having any basic fundamental knowledge on the biological system. So biological systems are so complex, so we cannot jump very easily to one place to another. So we have to go very slow, learning many things, because intricacies of nature, even if you spend the entire lifetime, you cannot even understand a small bit of it. So that is nature. Nature has got all the mysteries and intricacies. So as kids, you have to start from the school, start loving nature, loving algae, and try to identify and observe algae for how they behave, how they move, how they divide, how they reproduce. All these observations and small identification and other knowledge you develop, that will develop you as an algae pruner and also algal biotechnologist later, to use algae for the human welfare.